Bertil Fredholm, who's made really important contributions in the purinergic signaling field, but his main interest has always been adenosine. So we run parallel paths. It's not that there's a huge conflict. And personally, I think it's a big mistake to separate discussion of the actions of adenosine with that of ATP, because wherever ATP is released, it does rapidly break down to adenosine, and both receptors are usually involved. In the case of transmission, postsynaptically, it's the ATP receptor. Presynaptically, as a neuromodulator, it's the P1 receptor, the adenosine receptor. And sometimes adenosine and ATP, like in Latinia coli, act synergistically. The breakdown product, in fact, enhances the effect of ATP. You can't really divorce these two signaling molecules, in my opinion. But there has been, fortunately now, in the latest purine meetings, which are held every 2 years, in the beginning it was nearly all 95% adenosine. Then it switched in the 90s to more like 80% ATP. And now the two tend to be treated together at these meetings, which pleases me a great deal. Although I myself have not worked nearly so much on adenosine receptors as ATP receptors, they are undoubtedly extremely important. In the beginning, the drug companies were much more interested in the adenosine P1 receptors than ATP. The chemists found developing antagonists for P2 receptors daunting, and adenosine was a G protein coupled receptor, the kind of thing which they were more familiar with. And they did develop very good agonists and antagonists, but on the whole, the therapeutic developments with the adenosine receptors have not been that successful, because they're all very ubiquitously distributed. So to get localized effect, it has been successful for supraventricular tachycardia. And there are very interesting developments in the brain, especially Parkinson's disease with A2A receptors interacting with dopamine, in sleep, in various central nervous system maladies. Adenosine receptors are important.